Hello, I'm Jason, and I'm getting ready for tennis. And on that journey, I wanted to talk about the anatomic basis of blinking. Blinking is the coordinated opening and closing movements of the eyelids. It can be both voluntary and involuntary, which is further broken down into spontaneous and reflex. Spontaneous blinking is centrally controlled and regulated by activity of the caudate. Reflex blinking will be discussed later in the video. Let's look at the anatomical structure of the eyelid. Superficially, we have the skin, the thinnest in the human body, with virtually no subcut fat underneath it. Next, the striated fibers of the orbicularis oculi, which are arranged in concentric rings. It has two parts, an orbital and palpable one, which is further split into preceptal in red and pretarsal in black, which arise from the medial canthal tendon here and interlace at the lateral palpebral raphe here. Posteriorly, a membranous sheet lies underneath the orbital septum that is continuous with the periorbita. It is this structure that separates the eyelids from the orbital cavity. Next, the tarsal plates, a dense fibrous tissue that provides structural integrity. They are crescentic shaped and contain the meibomian glands, which discharge their secretions at the eyelid margin. Attached to each tarsal plate are the superior and inferior tarsal muscles, which help raise and lower the eyelids respectively. Just above the superior tarsal muscle is the levator palpebrae superioris, which inserts posterior to the orbital septum. It has a wide aponeurosis, creating a horizontal furrow in the upper eyelid. It originates from the undersurface of the lesser wing of the sphenoid and has a slightly nasal course. Finally, the palpebral conjunctiva, which is a thin mucous membrane that is reflected at the superior and inferior fornices. It is richly vascular, which can be appreciated in the reddish color when averting the eyelid. The eyelids are supplied by branches of the external carotid anteriorly and posteriorly by the lateral and medial palpebral arteries, which come from the lacrimal and ophthalmic arteries respectively. The venous drainage is from the corresponding veins into the ophthalmic and facial veins. Lymphatic drainage from the lateral lids is to the preauricular and parotid lymph nodes. Medially, it is generally towards the submandibular nodes. Embryologically, the eyelids come from surface ectoderm, which is seen here and over here, which forms the skin, the glands, and the conch, and the secondary mesenchyme here and over here, which forms the muscular components. The major phases are eyelid formation, fusion by the 10th week, and separation by week 26 to fully mature by term. In terms of muscle action, closure of the eyelids is brought about by the contraction of the pretarsal fibers of the orbicularis oculi, innervated by the temporal and zygomatic branches of the facial nerve. Opening of the eyelids is brought about by the contractions of the levator palpebrae superioris, innervated by oculomotor nerve. Some assistance comes from superior tarsal muscle, which is innervated by fibers of the superior cervical sympathetic ganglion. The lower lid has the inferior tarsal muscle and the capsulopalpebral fascia connected to the sheaths of inferior rectus and inferior oblique. A lesion of the sympathetic fibers can lead to a partial ptosis, which is one of the clinical features of Horner's syndrome. In terms of function, blinking can be likened to a car windshield wiper. You can see here my car's window is quite dirty, and with the wiper action of the lid, dust and debris can be removed. This physical action assists in the lacrimal pump mechanism to secrete mucin and meibum, key components of the tear film that coats the corneal surface. They also protect the eye from exposure. Alright, so we've made it to the tennis court. Let's play. Jason serves and goes in for the volley. Decent return, volleyed back and... Ooh, nasty shot to the face. Let's take it in closer. And in slow motion, we can see the first line of ocular protection, reflex blinking. This occurs in response to any corneal stimulus, such as a tennis ball directly stimulating the free nerve endings of the nasociliary branch of the trigeminal nerve, V1. The afferent fibers then synapse with the spinal trigeminal nucleus in the brainstem, which projects to the facial nucleus. It then synapses with bilateral connections along each facial nerve to the orbicularis oculi muscle, evoking eyelid closure bilaterally and tear production.